Geometry lesson 3-3. The other day we were discussing corresponding angles, alternate exterior angles, alternate interior angles, and consecutive or same-side interior angles. And I mentioned that oftentimes we use those concepts with parallel lines, and so today we're going to take that concept and find out if we do have those type of angles involved with parallel lines, what results and what can we glean from there. So our first one is corresponding angles postulate. If the two parallel lines are cut by a transversal, which we've been looking at before, then the corresponding angles are going to be congruent. Alright? So as a demo of this, here we have two lines being cut by a transversal. This little symbol of the arrows means that this line and this line are parallel to each other. If we do have parallel lines, then what happens is the corresponding angles become congruent. If I were to label more, and I would say this angle is exactly the same as that angle, and I could say that this angle is exactly the same as that angle, and this angle is the same as that angle. Alright? So 1 is the same as 2, blue matches up with blue, they are congruent, they'll be exactly the same. If one of these lines that's being cut is no longer parallel, it just moves a little bit, these wouldn't be parallel, and it would change those angle measurements, and they would no longer be the same. If you took one of these and you said, okay, this right here, that's my angle measurement right there, and you took it and you moved it down here to this one, it would fit in exactly the same location. And the reason? The parallel lines cut by a straight line, a transversal, will create a situation where the corresponding angles are exactly the same. They are congruent. Alright? Now let's assume that the next three theorems all deal with parallel lines cut by a transversal. So we don't have to keep repeating the same information over and over again. Each one of these is going to look like this problem here. Two parallel lines cut by a transversal. Alright? Our first assumption on that is this. Alternate interior angles theorem. We talked about alternate interior angles. They're on opposite sides of the transversal, and they're between the two parallel lines. What results is congruent alternate interior angles. Therefore, angles 3 and 4, this angle right here, is exactly the same as that angle right there. And this angle is exactly the same as that angle. Alternate interior. Alternate because they're on opposite sides of the transversal. Interior because they're between the two parallel lines. If I told you that angle 3 was equal to 40 degrees, then angle 4 would be 40 degrees. Again, assuming we're dealing with these same parallel lines, now we have consecutive interior angles. If you recall, it's also known as same side. Then the pairs of consecutive interior angles are always going to be supplementary. They are not going to be congruent. It means that the two of them add together to make 180 degrees. Right? Maybe this one right here is 80, and maybe this one up here has to be 100. The two of them are going to add together to make that supplementary line. Now, recall what we just talked about. We just said that alternate interior angles, which means that this angle and this angle are the same, that means this would have to be 80. And this is an alternate interior angle over here, which means it's got to be 100. But again, those are same side or consecutive interior angles. They're going to be supplementary as well. And our last one, that leaves us with the alternate exterior angles theorem. The pairs of alternate exterior angles are going to be congruent again. So now the outsides, 5 and 6, this angle will match up with that angle. And this angle will match up and be congruent to that angle. There's a lot of information that we can actually get. If we're dealing with parallel lines cut by a transversal, I only need one angle given to me, and I can find the other 7 based on these concepts. Alright, perpendicular translation theorem. If a translation is perpendicular, now again, a translation is the line that's being cut, that's doing the cutting. So if it's perpendicular to one line, then it is perpendicular to the second line. Alright? Here's what we have. So if we know we're dealing with parallel lines, and one line is perpendicular, it's going to hold true that it has to be perpendicular down here. The reason? Think about all the stuff we just talked about. This corner right here corresponds to that corner right there. They're going to be exactly the same. So if it's 90 degrees there, it's got to be 90 degrees there. So here's our if-then statement. In more symbols, we have if j is perpendicular to k. So if j is perpendicular to k, then and these two are perpendicular, or parallel, then J is going to be perpendicular to H. That's the perpendicular translation theorem. Alright, we have this diagram and we would like to fill in all the information that we can. Now because we have two sets of parallel lines, this line is parallel to this line, and these two horizontal lines are parallel to each other, we have to look at them somewhat separately. Let me get rid of those red lines, I don't want them there. Okay, the measure of angle 1 is down here. That's the measure of angle 1. And we just learned there's some connection between the two that are on the same side of the supplement, or the same side of the transversal, and in between the two parallel lines. Right? We learned that back here with consecutive interior angles theorem. The two that are on the same side will always add together to be 180 because they are supplementary. Therefore, 100 plus what is going to be 180? The measure of angle 1 is 80 degrees. So I know that's 80 degrees. I also need to find out what the measure of angle 2 is. Alright, well we can figure out the measure of angle 2. Because this line right here is parallel to this line right here, and that's the transversal, what are these two called? They are called alternate interior angles. And we learned about alternate interior angles back here, and we said that they were always congruent to each other. Alternate interior angles are congruent. That means if that's 100, up here is 100. So we just found that's 100 degrees. Alright, and our last one is angle 3. The measure of angle 3 is in the exact same location as the measure of angle 1 is. Therefore, they are corresponding angles. Corresponding angles are always congruent, so the measure of angle 3 has to be 80 degrees. And in fact, you could do a whole lot of filling on the rest of these if you wanted to. Alright, example number 2. How many actual angles in example 1 are equal to 100 degrees? Well, if that's 100, the corresponding angle over here is 100. And there's one that's 100 there. This also corresponds to this spot, being 100 degrees. And if that's 100, vertical angles would say that that's 100, and it corresponds with that location there. So those two match up with those two. If that's 100, then it has to be 100 here because of vertical angles, and also that spot corresponds to that location on that intersection. And if that one's 100, then it's got to be 100 over here, which is in the same location as that one, so it's corresponding. And if that's 100, then down here is 100. You'll notice that there are two sets of 100 each time, which gives us a total 2, 4, 6, 8 different degrees, different angles that are 100 degrees. There's a lot of these. This line, this angle right here, and this angle right here, alternate exterior angles. This one, alternate exterior, alternate interior, alternate interior. So it says how many angles are equal to 100 degrees? We would say 8. 8 of them match up to be that value. Okay, find x and give reasons for each one of our steps. So here we have an angle right here that says it's x minus 8 degrees. All right? We've got an angle right here that's 1 degree. We are going to make, this is also given to us, I just forgot to put it on there, that these are parallel lines. All right? So the fact that they're parallel lines means we have all these relationships between interior consecutive sides, alternate exteriors, a lot of things that we can do. This right here, 72 degrees, and this number 1, they're vertical angles. So you can figure out right now that angle 1, the measure of angle 1, is 72 degrees. And we know that because they are vertical angles. Erase that whole thing. Vertical angles. Okay. So now the 72 degrees is right here. Okay? Because we have these two that are interior here, we know that those two are going to add together to make 180 degrees. So we can say that angle 1 plus x minus 8 equal 180 degrees. And our reason for that is those are consecutive interior angles. All right? Consecutive interior angles are the ones on the same side of the transversal, and they always equal 180 degrees. So back here, I'm saying that these two on the inside, same side of the transversal, are equal to 180 degrees. So that would be our theorem that states the consecutive interior angles theorem. So consecutive interior angles theorem. And I'll just abbreviate theorem. I knew I was going to do that. Lag. Okay? Alright, from there, I think you can put that 72 degrees right in there for angle 1. And you can say that 72 degrees plus x plus -8, just change it right now, equals 180. And all we did is use substitution. From there, we will simplify, and we'll add 72 and -8 together to give ourselves 64. Oops, 64 degrees plus x equals 180. That was just simplifying. We simplified what we had on one side, so simplifying. Next, we will take the 64 and subtract it from both sides. So if we subtract 64 from both sides, I'll do that in blue, minus 64, minus 64. We end up with x is equal to 116. And that was the subtraction property of equality. Subtraction property of equality. We have now found the value of x, and we've given reasons for every step. Vertical angles state that angle 1 is 72 degrees. We add angles 1 and x minus 8 together to get 180 because they are consecutive interior angles. We substitute the value of 72 in for angle 1. Then we have that substitution. We simplified, and we put 72 plus -8 to give 64. We subtracted 64 from both sides, and that was subtraction property of equality, and x is now alone. Our last problem, again, we are trying to find the value of x. We don't need to give the reasons in this one. Let's think about what we have here. This is a little bit difficult at first. People see that this triangle in here, and they forget that they are actually dealing with some transversals. If you pretend as if this line were to continue, and it went like this, most of you would realize, I've already stated that these two lines are parallel, that this angle here matches up with that angle there. And this angle here matches up with that angle there. So if these two are the same, and these two are the same, and that one's 70, you now know that that space right there is also 70. Okay, and we know that this entire measurement from here to here is going to make 180 degrees. So all I have to do is put 70 and x minus 20 all together, and I'll have 180 degrees. 70 plus the x minus 20 must equal 180 degrees. Go ahead and we plus negative here, that's 1, that's 1. Now that it's all addition, we can add our like parts. 70 and -20 makes 50. 1x and 1x makes 2x. Still equals 180. And I solve my two-step equation. I subtract 50. And I get 2x equals 130, which means I'm only one step away. Divide by 2. Half of 120 is 60. Half of the extra 10 would be 5, so x is 65. And in fact, that 65 is a measurement right here that would be a degrees. If I put 65 up there, 65 minus 20 is 45. 65 and 45 together makes 110. 110 plus 70 would make the 180 for these being interior consecutive angles. All right?